I will be talking about the nitrogen insurance we have been working that we found to be a market-based strategy that could improve farmer profitability and reduce environmental losses. My name is Germán Mandrini, and this is a work that we have been doing with the list of co-authors that you see there. So as an introduction, let's talk about nitrogen management in corn production. Nitrogen fertilizer is one of the most critical inputs to crop productivity and one of the costliest. In 2005, 7 land-grant universities in the Midwest designed the maximum return to nitrogen, or MRTN, which basically they agreed on a methodology that they will use to recommend nitrogen. Still, 64% of farmers overapply nitrogen. Among the reasons, there are many behavioral economic studies, and we can mention farmers try to maximize yield instead of profits. There is inertia from yield goal methods and risk aversity, or farmers fear not having enough nitrogen more than they fear wasting a little bit more on fertilizer every year. So excess nitrogen has negative effects on profits and the environment is both in water quality and greenhouse gases emissions. So a little bit of theory to understand where this nitrogen will be located in a nitrogen response curve. So here is a typical nitrogen response curve. The y-axis, the x-axis is the nitrogen rate, and the y-axis is dollars per hectare. When we increase the nitrogen rates, usually we increase yield at the beginning to a point where there is a plateau. When we multiply the yield times the price of corn, that is the yield return curve that you see here. When you subtract the cost of nitrogen from that return, you get the nitrogen profits. And that curve will have a maximum that is called the EONR, or economic optimal nitrogen rate. And then the nitrogen losses follow a hockey stick pattern where they increase almost linearly after the EONR when the crop is at maximum uptake capacity. So when we think about programs or policies that could reduce nitrogen use, we can think about 3 zones in this curve. One is those farmers that overapply nitrogen, when they switch to the EONR, they increase their profits. So those programs will provide a profitable reduction. So they will increase profits for the farmers. Then there is a flat area around the EONR that we can think that as a free reduction. So farmers going from that upper end of that flat area to the lower end, they don't change profits. So that could be an environmental benefit at no cost. And then if we want to go below the lower end of that flat area, we might need external farm funding or a way to compensate those farmers. So the insurance that we will be talking today is in that area. It's in that profitable reduction. So it increases profits, and also is the area where the nitrogen losses are maximum, right? So if we reduce there, we increase profits, and we have the most impact on the environment. So are there farmers applying in that area? There is a study from Sellers in 2020 where they survey farmers in Illinois and they compare that rate with the university recommendation. And they found that 64% of the farmers are 21 kilograms of nitrogen above the university recommendation. It follows this distribution, which is the one that we use for the methodology in the insurance. And even 5% apply more than 80 kilograms on top of the university recommendation. So what is this insurance that I'm talking about? This will be a product that will be available for farmers that overapply nitrogen. So those that are above the science-based recommendation. Those farmers will make a small plots with their end rate in 10% of the area, and they will use the science-based recommendation on the other 90% of the area. A little bit about vocabulary. In insurance, we call premium what we pay to the insurer. So when we pay our car insurance, that is premium. What we get back when something happens, that's the compensation. So in our products, farmers will pay a premium that is half of the nitrogen they are saving when they adopt the science-based recommendation. So imagine that a farmer rate is 230 kilograms of nitrogen per hectare, and the science base is 180. Imagine, for simplicity, that 1 kilogram of nitrogen is $1. So when they switch, they will be saving $50. We split that, and farmers will pay $25 as a premium to the insurer, and they will get the other 25 as an upfront cost reduction for them. In exchange of that, farmers will obtain a compensation if the profitability of the high end rate is higher than that one on the science-based rate. So at harvest, we compare the profits. If the ones on the rate are higher, they get paid the difference. And an important caveat is that we factor in the premium as a cost on the science-based plot. So that way, the farmer always recovers the premium, at least recovers the premium. So the farmer is always making the same profits or more with the insurance. So will this work? We use a large-scale modeling dataset that is published. It was done using AppSim. In that dataset, we have 4,270 fields and 30 years of simulations. On each field, we have at least a maximum of 3 soils, and on each soil we have a response score. So we use those 64,000 response scores to test the insurance. So let's look at the economic performance of this insurance. One of the first things we found is that the over-application rate is one of the main drivers of the results. So the over-application rate is that difference between what the farmer is applying and the science-based recommendation. So in the case I presented before, it was 50 kilograms. So we saw that that is a main driver of the results. Let's look at the premium. As I said, the premium is set as half of the nitrogen savings. So the more the application rate, the more the premium will be. The farmer will pay more because they are saving more when they switch. The average indemnity increases a little bit at the beginning, but then it reaches a plateau. The reason is that those farmers that are over applying, the probability of them making more money than the science-based recommendation is very low. So when they make more money, but the probability is lower. When you multiply those two, you get more or less the same number, and that's the plateau. The profits are the difference between the previous two graphs, A and B. So the profits for the insurance provider. And we see that those increase because one is increasing, the other one is more or less stable. So the difference is increasing. Something important here is that at the low end, this is not profitable. So that's why we set a threshold of 40 kilograms per hectare when this becomes profitable. So those farmers that are close to the science-based recommendation, this wouldn't be viable, but it becomes viable after that. And the value for the farmer, this is the difference in profits between having and not having the insurance. And this is always positive because of how we set it up. As I said, we consider the premium as a cost, so the farmers always recovers the premium, so the farmers always makes more money, and that value is higher with the over-application rate. So one thing to see here also is that both the profits for the insurance provider and for the farmer are very high in those high over-application rate farmers, right? So those should be our best customers. If we were starting this insurance, we should try to find that 5% or 10% that over-applies the most first. The environmental performance is more or less as expected. Those farmers that over-apply more when they adopt the science-based recommendation, they reduce the environmental impact the most, right? So the nitrogen leaching benefits are more for those farmers that over-apply more, and the same with the greenhouse gases. And then this table, what we did is we estimated what would happen if we went now to Illinois and we implemented this insurance. So Illinois has 4.4 million hectares of corn. From those, 2.3 are not eligible. So 2.3 are below that 40 kilogram per hectare threshold, so they are applying reasonable rates. 2.1 are applying above that threshold, and from that we need 10% as the benchmark, those plots that need to keep the science-based recommendation, the farmer rate recommendation. So we will apply this on 1.9 million hectares. important, that is not any area of Illinois. That's the hotspot. That area is those farmers that are really over applying nitrogen. So when we enroll them in the program, they will switch to the science-based recommendation, and that will lead to a 31% reduction in leaching in that area. And when we do the weighted average, considering corn and soy in Illinois, that will mean a 15.7 reduction in leaching in the agricultural area of Illinois, which is a really good number because there is the Illinois nutrient loss reduction strategy that has a target of reducing nitrogen leaching by 15% in 2025 in Illinois that we didn't achieve. But with this, we will achieve that not only for free, but also increasing profits for the farmer and the insurer. We will obtain energy savings from producing less fertilizer. We will reduce greenhouse gases emissions, including CO2 and N2O. And we will provide value for the farmer of $14. So we will increase profits for farmers. And it will create profits for the insurer of $10.4 per hectare. Those profits are very important because we are proposing this as something that a private insurer or an NGO could take over and implement it, right? So we need this to be profitable, and that will allow the program to grow, to keep finding farmers, to expand to new areas, and like enroll the area that we need in order to achieve the environmental benefits we need. So the takeaways are a nitrogen insurance is a potential commercially viable solution to reduce nitrogen use by farmers. Some key implementation insights that, that we found with this analysis is one, that we should target those farmers that overapply, and there is that threshold that we found to be 40 kilograms. We might need to test this with other data in other areas, but the idea is that there is a threshold where this becomes profitable. And those high overapplication farmers get the most benefit from this and provide the greatest environmental benefits. We think that the design should encourage farmer participation, so they should see incentives to be part of this, to enroll. That's why we provide an upfront cost reduction. The farmer upfront knows that they are reducing the rate and saving money, and that comes with a guarantee that they will always get the same or more profit. So that's why we factor in the premium. And this presents a triple win opportunity. So it's higher profits for the farmers, profits for the insurer that will support the program over time, and environmental benefits for the society. So yeah, that's it. Thank you, and we are open to questions. Yes.
Can you explain a little bit more that you said that 10% of the area would be under different management? And what if the university recommendations are not the best recommendations? How does that change?
Yeah. So the 10% is this is for farmers that overapply, so that don't trust those university recommendations, we can say. So if the farmer is applying 230 and the university recommendation is 180, we will keep 10% with their area, and that is what we use to calculate the compensation, the difference in profits, right? So that way they can see what the profits will be with their rate and with the other rate, and like it's very transparent how we are calculating the compensation. And the error of the recommendation is factored in the insurance, right? So not always the university recommendation will be the best. That's when the farmer gets compensated. But the premium that we are getting is enough to cover those compensations. So overall, in the long term, over many years and many fields, the university recommendation is better than what the farmers are applying in this case, and the math works, right? Like the premium is enough to cover that difference. So it also is like a risk reduction for the farmer. Those farmers that don't trust the university recommendation, they can basically adopt it and don't have to bear the cost if the university recommendation doesn't work. Thank you for the question.
Unfortunately, we are out of time for more questions, but thank you for your presentation.
Thank you.